Welcome back to Crushing Design Patterns in .NET. We've explored how to swap algorithms with the strategy pattern and how to broadcast changes with the observer pattern. Today, we are tackling a different kind of problem: complexity. What do you do when you have a powerful but complicated set of subsystems that is difficult for a client to use? The answer is a simple yet incredibly powerful structural pattern: the facade pattern. Let's see how our expert Aarohi uses a facade to create a simple, clean entry point to a complex process. Aarohi, welcome. Today's interview scenario is for a home theater system. To watch a movie, a user has to perform a series of complex steps. Turn on the Blu-ray player, power up the amplifier, set the amplifier to the correct input, turn on the projector, set the projector to its HDMI input, and dim the lights. This is too complicated for the client code to manage directly. How would you simplify this entire process? What is the initial problem with the client code having to manage all these subsystems directly?
The primary problem is tight coupling and high complexity. The client code, say the remote control part of our application, would need to know about every single class in the home theater system: the projector, the amplifier, the lights, the Blu-ray player, and so on. If we ever add a new component like a popcorn machine or change how one of the components works, we have to update the client code. This is fragile and violates the principle of encapsulation. The client knows way too much about the internal workings of the system.
How does the facade pattern solve this problem of complexity and coupling?
The facade pattern is the perfect solution. Its intent is to provide a unified, simplified interface to a set of interfaces in a subsystem. The facade defines a higher level interface that makes the subsystem easier to use. It's like putting a simple, clean front on a complex building.
What is the first step to implementing a facade in this scenario?
The first step is to create the facade class itself. I'll call it HomeTheaterFacade. This class will hold references to all the complex subsystems it needs to operate. The facades constructor takes in all the parts of the system it will be simplifying.
How do you create the simple, unified methods on the facade?
Now, we add the simple methods that the client will call, like watch movie and end movie. Inside these methods, the facade will perform the complex work of coordinating all the subsystem components. All the complexity is now hidden inside the facade.
How does the client code change now that we have the facade?
The client code becomes incredibly simple and clean. It only needs to know about one class, the home theater facade. The client is now completely decoupled from the complexity of the subsystem. It just tells the facade what it wants to do, not how to do it.
What is the main principle that the facade pattern enforces?
The facade pattern is a beautiful example of the principle of least knowledge, also known as the Law of Demeter. It says that an object should only talk to its immediate friends and not to strangers. Here, the client talks only to its friend, the facade, and not to the stranger components within the subsystem.
Does using a facade prevent a developer from accessing the underlying subsystems if they need to?
That's a key point. No, it does not. The facade provides a simplified interface, but it doesn't prevent access to the more complex functionality if it's needed. A power user or another part of the system could still interact directly with the amplifier class to fine-tune the bass, for example. The facade is an additional simplifying layer, not a restrictive one.
How does this pattern relate to API design, for example, in a web API?
The facade pattern is a core concept in great API design. Often, a single API endpoint needs to coordinate several different services: an ordering service, an inventory service, a payment service, to fulfill a request. The API controller itself, or a service it calls, acts as a facade. It takes a simple request from the client and orchestrates the complex interactions between the backend microservices, then returns a simple response. This hides the internal complexity of the distributed system from the client.
Can a facade be a simple static class in some cases?
Yes, in very simple scenarios, it can. If your subsystem components have no state and the operations are straightforward, Exposing them through a static home theater class with static methods like watch movie could work. However, for testability and flexibility, using an instance class and dependency injection, as we did in our example, is almost always the better, more professional approach in a modern .NET application. It allows us to easily mock the facade in our unit tests.
What's the key difference between a facade and an adapter pattern? They sometimes seem similar.
That's a common point of confusion. The key is their intent. An adapter's intent is to convert the interface of one class into another interface that a client expects. It's about making two incompatible things work together, like putting a US plug into a European socket. A facade's intent is to simplify the interface of an entire subsystem. It's not about changing an interface, it's about providing a cleaner, higher level one. Essentially, an adapter changes an interface to make it usable, while a facade creates a new, simpler interface to make it easier.
Can we use the facade pattern to manage legacy code during a migration?
Absolutely, and this is one of its most practical uses in the enterprise world. When you are migrating from a legacy monolith to a modern .NET Core microservice, you can't change everything at once. You can build a legacy facade that sits in front of the old, messy code. The new parts of your application talk to the clean facade. Behind the scenes, the facade handles the dirty work of communicating with the legacy systems. As you gradually rewrite the old code, you only have to update the facade, while the rest of your application remains untouched. This is often called the strangler fig pattern in architecture.
Does adding a facade layer introduce a performance bottleneck?
Technically, you are adding one extra method call in the stack. But in a real-world .NET application, the overhead is measured in nanoseconds. It is practically zero. The trade-off is heavily in favor of the facade. The time you save in developer productivity, easier debugging, and reduced maintenance far outweighs any microscopic performance hit. In fact, by centralizing logic in a facade, you often find opportunities to optimize performance, like implementing caching or reducing redundant database calls that would have been impossible to manage if the logic was scattered across the client code.
How does the facade pattern improve our unit testing strategy?
This is where the facade pattern really shines for .NET developers. Without a facade, if a class depends on 5 different subsystems, your unit test needs to mock all 5 of those dependencies. This leads to fragile tests that are hard to maintain. With a facade, the client only depends on HomeTheaterFacade. In our unit tests, we only need to mock one interface. This makes our test setups much cleaner and faster. It allows us to test the business logic of the client in isolation, without getting bogged down by the complex setup of multiple subsystems.
Is there a danger of the facade becoming a God object or an anti-pattern?
That's a very sharp question. Yes, if you are not careful, a facade can grow too large and start violating the single responsibility principle, SRP. If your home theater facade starts managing the movie theater, the kitchen's smart fridge, and the home security system all in one class, it has become a God object. The solution is to create multiple facades for different logical domains. You might have a media facade, a climate facade, and a security facade. A facade should be a simplified window into a specific subsystem, not a front door to the entire universe.
How does the facade pattern relate to the backend for frontend BFF pattern in microservices?
In modern cloud architecture, the BFF, Backend for Frontend, pattern is essentially a network-level facade. Imagine a mobile app that needs data from 10 different microservices to show a single screen. Calling 10 APIs from a mobile phone is slow and consumes too much battery. Instead, we create a BFF service that acts as a facade. The mobile app makes one call to the BFF. The BFF then orchestrates the 10 microservice calls on the fast internal network and returns one simple, optimized JSON response to the phone. It's the facade pattern, just scaled up to the distributed system level.
Aarohi, that was a crystal clear explanation. You've perfectly shown how the facade pattern can tame complexity and create clean, simple APIs for even the most tangled subsystems. If you're now ready to simplify your own complex code bases, give this video a like and comment below with a system you've worked on that could have used a facade. And be sure to subscribe to the .NET Way for more design pattern masterclasses. In episode 5 of our Crushing Design Pattern series, we are going to explore how to create objects without specifying the exact class to be created. It's time to dive into our first creational pattern, the factory method pattern. Thanks for watching. We'll see you in the next episode.